Hey everyone, welcome to UBTEB2018 your engineering sciences channel. In this video, we are going to look at a problem that involves calculating the hydrostatic force on a submerged surface. And the guiding question is as follows. A circular lamina 125 centimeters diameter is immersed in water so that the distance of its perimeter measured vertically below the water surface varies between 60 centimeters and 150 centimeters. Find the total force acting on one side of the lamina and the vertical distance of the center of pressure below the surface. Now, let us interpret this question. We see this is a circular lamina and it has perimeter which is equivalent to its circumference. So, one part of its circumference or one part of it is the lamina is tilted in such a way that one part of it is 60 centimeters below the free water surface and another part is 150 centimeters below the free water surface. So when you look at it in this manner, it means this water or this fluid is going to exert a hydrostatic force F that is required of us to calculate, and also we are required to determine the distance below the free water surface, which we can call H star, below which this hydrostatic force acts. So let us look at this question in details. Now, looking at the free water surface as here, then this circular lamina arranged in such a way that it is 150 centimeters at one part and 60 centimeters at the other part, all of it covering the circumference or the perimeter of the lamina. Now, since it is diameter of 125 centimeters, it means its radius, of course, is equivalent to 62.5. Okay? Yes. Now, it means where that hydrostatic force acts is the center of pressure, and let us call it P. Then G is the center of gravity, where the weight of this particular lamina is concentrated. And since we know this is a regular object, then it will always be at the center of the object. This angle it makes, since it is tilted, it means it will be inclined at an angle phi that we shall find out during the calculation. Now, look at the data that has been given to us. We know that first of all, this is water. The fluid in question is water, and therefore its density is 1,000 kilogram per cubic meter. Then the acceleration due to gravity is 9.81 meters per second squared. The diameter is 125 centimeters, which is equivalent to 1.25 meters. Okay, we know that first of all, hydrostatic force F is computed from rho times G times A, which is area, times H bar, whereby H bar is the depth or the vertical distance below the free water surface to the center of gravity or to the centroid of that particular object. Then A is the area of the centroid, area of the object. Now, the rho G, which is rho times G, is equal to density times 9.81, and this would give you 9810 newtons per cubic meter. Then area is equal to pi d squared out of 4. The diameter is 125, so it becomes 1.25 meters. So we square everything divided by 4, and this would give us 1.227 square meters. Let us proceed and see what else is required. We have said that H bar is the distance of the center of gravity or the centroid from the free water surface. If that is what we have already said, then let us proceed and see how to position H bar, how to position H star, which is the point of application of the hydrostatic force. Now, the lamina is 125 centimeters in diameter, meaning that from the center of gravity to the extreme end, any of the extreme ends, is the distance is 62.5 centimeters, and it is along the incline. Meaning we also have to indicate these distances, the 60 centimeters to one extreme end of the lamina, then the 150 centimeters to the other extreme end of the lamina. Now we need to also indicate h bar, which is the vertical distance from the free water surface to the centroid. That is h bar. Now if it is to the centroid, we already know that this angle is phi, and therefore we can calculate for those unknowns. The y star and the y bar, if required, we can calculate them given that we know the value of phi. So the point of application of the hydrostatic force, and y bar, the point of application of the weight of this particular regular object. Now, what is sin phi? Sin phi, we know sine of this angle is equal to opposite of hypotenuse. If we consider these triangles, all these triangles are similar in a way that they all share one common angle. So if I look at this, if I'm to use the sine of this bigger triangle, it will be opposite of hypotenuse. Now because I don't have the length of the hypotenuse, I forego that. The same thing with this, I don't have the length of the hypotenuse. But when I look at the, if I create a line here that is parallel to this, it will create an angle phi at this point. This angle is going to be phi because this line is parallel to this, and they are being joined by the same common inclined line. So this angle is also phi, meaning that sin phi can be obtained by using the distance from here to here, then also from here to there. Since I have the diameter of the lamina, and I can get this z because I know from here to here and I know from here to here. Therefore, I can say sin phi is equal to z out of 125, whereby I'm considering opposite of hypotenuse. But remember, z from here to here is equal to 150 from here to here minus from here to there. So that will be 150 minus 60, which gives you 90 centimeters. Then sin phi therefore will equal to 90 out of 120 gram. H bar, which is the vertical distance from the free water surface to the centroid of this lamina, h bar is equal to 60, that is from here to here, plus x, which is the distance from this point to G. Okay, so that means if I call it x, I can say h bar is equal to 60 plus x, which means if I use similarity of triangles, as I said, this triangle here, this small triangle is the same, is similar to this bigger one because they share a common angle here, and therefore I can express its their dimensions in terms of each other. Meaning that if I have z out of 125, which is considering for the bigger, I'm considering something like this. Okay, so this is x, remember this is phi, this is z. I know the distance from here to here. Okay, that is 125. I know the distance from here to here, which is 62.5 centimeters. Meaning, I can say this, since this is an angle of 90, this triangle here, this small one, is similar to this bigger triangle inside which this small one is. So it means I can say z out of 125 is equal to, remember, I need to correspond these dimensions. If I put z out of 125, it means what corresponds to z here for the small triangle is x. So it will be x divided by the hypotenuse. So the hypotenuse for this is 125, the hypotenuse for the smaller one is 62.5. Meaning that x is equal to, if I cross multiply, x will be equal to 62.5 times z out of 125. Remember, z is 90, so I can have 62.5 times 90 out of 125, which gives us 45 centimeters. Hence, the center of gravity is at h bar, which is equal to 60 plus 45, and this gives us 1.05 meters. Now we can use the h bar, having known all these other parameters, rho, g, and a. Now we also have h bar, we can substitute in and calculate for f. Therefore, this will be 9810 times 1.227, which is for area, times 1.05, which is for h bar, and this would give you 1263.8.7 newtons. Now, having gotten the hydrostatic force, it means we are left with determining the center of pressure, which is the point of application of this total hydrostatic force. So we know, according to the formula, I have one of the videos where I have derived this formula for submerged, for hydrostatic force on an inclined surface submerged in a fluid. If you haven't watched that video, I'm going to share its link in the description of this particular video. So h bar, h star, which is the center of pressure, that is from the free water surface to the point of application of this hydrostatic force, is equal to Ig sine squared phi out of A h bar plus h bar, whereby Ig is the second moment of area about an axis through the centroid of the object, which is the lamina. And since it is circular, its Ig, or the second moment of area, will be pi times d to power 4 divided by 64, which gives us pi times 1.25 to power 4 divided by 64, and this would give us that value. Therefore, h star would give us 0.11984 times sine phi is 0.72, so this will be 0.72 squared, then divided by 1.227 times 1.05. Then we add there 1.05, which would give us 1.098 meters. That is our h star. Thank you so much. For us in the next